SQLite versus SQL versus XML versus TSV, Data Wrangling for AI Projects. Introduction. PatentLLM, Patent Search AI, and Hanrei-DB, Case Law Search AI, are both personal projects built with Python plus Streamlit plus SQLite. Through their development, I realized that the choice of data format directly impacts an application's maintainability and development speed. This article organizes the criteria for choosing between different data formats and the implementation know-how gained from actually using them. SQLite 3, Application Backend. Both PatentLLM and Hanrei-DB use SQLite 3 for storing searchable data. Reasons for selection. No server process required. Self-contained in a single .db file. FTS5, full text search, is available out of the box. Python's module is part of the standard library. Good compatibility with Streamlit, read-heavy use cases. In Hanrei-DB, case law texts are indexed with FTS5, combining keyword search with AI summarization by Gemini 3.1 Pro. Points to note. Weak against concurrent writes, single writer even in WAL mode. Since Streamlit scripts are re-executed for each request, connections should be cached or managed within the request scope. No issues up to several 100,000 records. Beyond that, index design becomes crucial. SQL, data exchange with LLMs. SQL is the easiest format to handle when interacting with the Gemini API or local LLMs. Advantages. 1 record per line allows for stream processing, no need to load everything into memory. Easy to append, just append to the end of the file. If one line is corrupted, it doesn't affect other lines. Contents can be instantly checked with the command. In PatentLLM, I built a pipeline that converts CSV data from the Japan Patent Office into SQL before loading it into SQLite. This CSV SQL SQLite flow facilitates intermediate data validation. XML, blog post management. This blog, Local AI Dev Log, itself manages article data in XML. It's configured so that Fast API reads the XML on request and renders it with Jinja 2 templates. Reasons for choosing XML. The number of articles is only a few dozen, not enough to warrant a database. Is in the standard library, meaning zero external dependencies. Can naturally express hierarchical structures like categories and tags. Manual editing is possible, human-readable. While it would be better to migrate to SQLite if the number exceeds several hundred, XML is sufficient for managing around 30 to 50 blog posts. TSV/CSV, importing external data. Data acquired externally, such as government data, financial data APIs, and scraping results, often comes in CSV or TSV format. PatentLLM imports public data, CSV, from the Japan Patent Office. CSV pitfalls. Encoding issues, shift_JIS, UTF-8 with BOM. New lines and commas within fields, improper quoting. Lack of type information, distinguishing numbers from strings is the responsibility of the reader. As a countermeasure, inserting an intermediate step to convert to SQL during import makes data validation easier. Summary of usage. Application Backend, Search, Persistence, SQLite 3. Data transfer with LLMs, Training data SQL. Management of a small number of structured content XML. Entry point for external data import CSV/TSV, as an intermediate step. Common principle, choose text-based formats whose contents can be easily inspected with tools like OR. Binary formats, e.g., Parquet, protocol buffers, can wait for their turn until scenarios involving millions of records or where type safety is essential.